Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to the online lecture on MATLAB simulation of control systems. Today we are going to discuss this paper, finite time stability under denial of service. But actually what we are going to do is we are going to discuss an example of event driven control. So event triggered control is something that is quite latest and common in the control systems community, and with the help of this paper my main purpose is to get you familiarized with the event triggered control. So this paper particularly uses the event triggered control for the scenario where we have some sort of a plant and actuator sensor system, and there is some communication network where there could be an event of denial of service. So in case of denial of service is sort of like an example of an event that happens excuse me, and based on that event the controller applies different type of action on the plant through the actuator. So without any further delay, we just jump straight into the example of event driven control in this scenario. So but at least I have to tell you what kind of systems are discussed in this paper. So system discussed in this paper are very simple: x dot equal f of x comma u, which is non-linear typical equation of a non-linear dynamical system with initial condition x naught, and then we have the event triggering mechanism. So t of k plus 1 will be the infimum over all t greater than tk under a certain condition, which is the condition of the event. But in our case, because we are using ODE 45, so this t will be one of the time steps that are used in ODE 45 solution in MATLAB. So we don't have to worry about this infimum over all t greater than tk. Then there is an example. This is the simulation study example where the system is x dot equal minus sine of x times the square root of the absolute value of x plus u. And this system is very simple. We can just write the equation here. This is the equation of the system: minus sine of x times square root of absolute value of x plus u. But of course we have to write, so here u is equal to this u is equal to minus 2x plus e. E is the difference between, if you go up to the event trigger condition, so this here, e is the difference between the state value at the previous event and the state value at the current time t. So remember that current time t will always be the time greater than the time of the previous event. So coming back here, so u, the control is minus 2 times x plus e, where e is the difference between the value of the state at the previous event and the value of the state at the current time. So basically u is equal to minus 2 times the value of the state at the previous event. So that is the control, which is written here. If you come here, so u is equal to minus 2 times x plus e. Now the final thing is, how do we define e? That is the main challenge in implementation of event triggered control in MATLAB. So because it uses the value of the state at the previous event, so somehow you have to save that value somewhere. So in my case I have opted to save the value of this value of the state at the previous event as a global variable. So I have defined this function get global x. So get global x is, if I open this function get global x, so it's a very simple function. You just define a global variable x and return the value of the global variable. And similarly, there is going back to this, so we get the value of the state at the previous event from a globally defined variable value. Then E is equal to the value of the state at the previous event minus the value of the state at the current time, and this is the condition of the event described in the paper. So condition of the event is that if here they have this condition, so 32e square greater than the absolute value of x raised to the power 1.5. If this is true, then we have the event. So we have if condition. So if 32 times e square is greater than absolute value of x time raised to the power 1.5 and t greater than 0, because t always has to be greater than the the event. If the first event is at t is equal to 0, then the second event cannot be at the same time. So that is why I have added this condition. Then we have another function, set global. So whenever a new event occurs, we change the value of the state at the event. So we update the value of the state at the event whenever this condition is true. So set global is another a very simple function where we give the value of the global variable x and we assign x equal to that value, which is input to the function. So two functions are used, get global x and set global x. Okay, so this so far, so this is the file which we will be using to solve the differential equation. But this is coming back to the differential equation. First of all we get the value of the state at the previous event, then we define E, then we see if the event has occurred in the current time or not. If the event has occurred in the current time, we set the value of the state at the event, we update the value of the state at the event, and this is just for a pointer. Whenever the event occurs on the command window, it will show that event equal to 1 and the corresponding time of the event will also be shown. This is DLM write function, which will write EV event equal to 1 whenever an event occurs. So I want to save the event for plotting purposes as well. So if event does not occur, then we will write 0 in the EV text file and we will append the values one after the other. Then u is equal to minus 2 times x plus e, and this is all of the rest is very simple. And now we come to the file that we use to call this function. We first of all set the global to the initial condition of the state. So this is the value of the state at the whenever you are starting, there is nothing before you start. So set value of the state variable at the previous event you can start it from the value of the initial condition of the states. So then you can call this function et event triggered control with denial of service example. Then you can plot t comma x, and you can also plot the input u using the same logic that you applied in the main file here. So same if else event condition and so on. So this yeah, I think I can just ignore this part of the code, although it does not make much difference, but u should be calculated using the same logic that is used in the other file. So now we run this and change directory, and we will soon have the results. So you can see here that these are the results. This is the control signal. These are the state variable values. So state goes from 3 to 0, and these are the times at which the events occurred. So different values of t and the corresponding event. So now that you have obtained this, and remember that we also had what I accidentally closed this file, so I will have to reopen it. Et so remember that we also had this thing where we wrote the events in the ev text file, so we can get this ev from dlm read command. So we can get this ev, and then we can use the stem function to plot ev. So stem ev will, oh, I had to close the let me close the existing graphs, close all, and then we can have stem ev. So stem ev, you can see here that there were events at the beginning for a few seconds, and then there was no event. So these are the events happening at the beginning, and if you look at the paper as well, so this is the corresponding case in the paper. So the events are happening up to the first 2 seconds, and then the state goes from 3 all the way down to 0. The same case happens for us. There are some events at the beginning, and then there is no event for some time. And I have plotted the number of events as not versus time, but just versus the number of data points. So I have plenty of data points. You can imagine if the data is equally spaced, then we have like 4000 data points for about 5 seconds. So about 1000 data points correspond to 1 second. So we have a little bit lesser number of events as compared to, I think, what is depicted in this paper. But anyways, it's but if I look into here, so you can see that my last event occurred at about 2 seconds. So yeah, I'm not really sure because I have not plotted it versus time. So my events are also occurring up to the 2 seconds, which is inconsistency with the what is depicted in the paper, that the event occur up to 2 seconds. And this last event you can ignore, because this event the event after 1.99 seconds, the final event at t is equal to 5, this is some sort of an outlier that can be ignored. Then coming back to, let me close all again and plot t comma x. So this was our state trajectory, which is also in consistency with this one. So that is all for the event triggered control using MATLAB. Let me summarize at the end what are the tricks that you need to apply event trigger. First trick that you need is you need to know how to define the get global and set global. So how to deal with the global variable, because you will be needing the state variable value at the previous event in order to implement the event driven control or event triggered control. Second thing is the event condition will be implemented using the if else structure. And the third thing is you can save the events, the occurrence of events. You can save anything at this time of occurrence. You can save the timestamp, you can save the event value equal to 1 or anything you want. Then the control is of course depending upon this state value at the previous event, and this is the very simple first order system. So I hope that this was a simple example that can help you understand how to implement more complex event triggered control systems. And that is all for now. Thank you for watching this video.